What's up, everybody? This is SirCheddar, and I'm going to be bringing you a different type of video today. Today, I'm actually going to be bringing you a video about how I go about designing a keyboard. So, the program I'm going to be using for this is Rhinoceros 3D, and I do want to mention that the way I do it is not necessarily the optimal way. It's just the way that I enjoy doing the design. So, I mean, feel free to make suggestions if you have like tips for me and such, but I don't I just really do this for fun, and I don't really use this program technically to any professional capacity. So, yeah, if you can learn something from it or if you think it's interesting, that's cool. And I did want to get out some content for our YouTube channel because I've been slacking so bad. So, yeah, let's get started. So, and also I'm going to be doing this just like one cut. We'll do it live. So here is a file that I imported as a DXF file from. You first create a layout on Keyboard Layout Editor, and then in order to bring it onto a CAD program, you have to save that data onto a Swill keyboard design, and then you can download the DXF. So the two websites you're going to be using are Keyboard Layout Editor and then Swill Keyboard, and that allows you to get this 2D layout file, which is really like, this is the hard part. So without having Swill's Builder and Keyboard Layout Editor, this would be a nightmare. But because I do have access to those, it makes this process way quicker. So, I mean, you can easily design a keyboard in like 30 minutes or an hour. It just won't be the most refined design. But, alright, I guess let's get started. And I have an idea of what type of design I want to do, but it's kind of flexible as I go, depending on if it's fun or not, or if I like how it looks or not. So, alright, let's go. Let's get started. So first, I'm going to extrude this to the thickness that I want for the keyboard, which is 1.6 centimeters. So that's going to be the thickness that I have for this design. And now I want to do some distance dimensions for this, which is 30.48 and 11.43. So recently, a trend which I've been kind of working towards is rounding off numbers for like outside dimensions, because for some reason I don't like when they're not rounded off. I don't know if that's actually like a design principle, if a designer knows, but it really does bother me that some of the dimensions are not precise rounded numbers. So I like to round these off. So for my case design, because that was 30.48 and 11.43, I'm going to add around 3.5 to both of them to round them both up to the next whole number. So it'll be 34 and 15. So in order to get the base layout for this, it's 34 centimeters, 15 centimeters, and then 1.6 centimeters. So this is our keyboard. Okay, so now I'm going to create a little diagonal line in there. I'm also going to change this layout to a wireframe so I can see inside. Then I'm going to hide this because there's a lot of stuff going on there. It's kind of confusing. And I want to make sure I grab the center of this. So I just run my cursor on the line until I hit the snap. And there, now I know it's lined up with this square. So now both these squares, if you switch to one of the side views, they're perfectly lined up. Perfect. So now I can bring that guy back. Okay. Oh. Okay. That was from I don't know. That was a remaining file. Just ignore that thing that I just deleted. So, so now the next step is I want to, so I'm gonna create a line around the plate design, and then I'm gonna offset it. Just a small amount, let's say 4 millimeters. Just this is the reason why I'm including this, is to give the plate, to give the PCB extra space within the case of the keyboard, because I don't actually have a PCB for this design, so I could estimate it, but I'm just gonna give it 4 millimeters. Better safe than sorry, because I wouldn't want the keyboard to not fit because I didn't give the PCB enough space when I could have just given it as much as it needed. And I'm going to drop this down 1.5 millimeters. So the reason why I just created this little layer as 1.5 millimeters, is because that is going to be the thickness of the plate. However, as I'm doing a integrated plate design for this, I'm not actually supposed to cut the plate. I'm just supposed to offset the inner little like trough area on the underside by the thickness of the plate. So actually, here's another change which I'm gonna have to do. So so after this, there's some changes I like to do. Actually, first I'm just gonna change this color to black, because when you import the DXFs, sometimes it gives you different colors, and those are white, and I don't like white. So now that I got them all black and I exploded the shape, so now these are all separate lines, I'm gonna make some changes to this here and also the space bar. The reason why I do these changes is because I don't really like having to do all these little machining angles, and because I use PCB mounted stabilizers on my designs, they're not actually needed. So, and I think that giving the stabilizers more space is better. I don't know if that's objectively true, but in my mind it makes more sense to give the stabilizers more space than less space. And I'm just going to retrace this little switch cutout. And then once this is done, there's also one on the other side at the enter, so I'm going to have to copy paste this guy. So now I got this guy. I'm just going to hide him for now, and I'm going to actually before I hide it, I should copy and paste it. Ooh, I changed my viewport. Now I'm going to grab the second one. I'm going to do something with that later. So now I'm going to hide this guy, and I'm going to delete this. Yeah, I missed a few there. Now, I'm going to throw this guy on that. Then I'm going to hide him again, and I'm going to delete this stuff. And a little bit more. I'm going to do these changes here. This cutout here isn't needed for PCB mounted designs, and it looks really ugly, especially on my style of designs I do, which is where the plate is like the top of the keyboard is, the top of the keyboard is like fully exposed, and you can see the switch bottom, so you don't want to have a huge cutout on your aluminum plate if you don't need it there. So that's why I cut that guy off. And yeah, so now that should be it. That should be it for the plate modifications. So now once again, I'm going to show everything, hide it again, and I'm just going to group the plate together. Also, I'm going to grab this little line here, and I'm just going to move it out of the way. Oh, there's another one. I don't know if I built that one or not, or if that was on the file. Okay, so I'm just gonna, for now, I don't know if I'm gonna need this later for some reason for measurements, so I'll just keep that there, just move to the side. Now I'm gonna group this together. There we go. Show. Okay, some progress. All right, next step. This is also not needed anymore. So now the next change I'm going to do is I'm going to fillet edge this square here. That doesn't need to be 0.65. Let's fillet edge 0.125. Let's see how that looks. I could probably do 0.25. Fillet edge 0.25. Yeah, that looks great. Okay, so I'm gonna fillet this out, these corners here. Okay, so now that's the inside like trough part of the keyboard. Now, when I'm ready, I can just boolean that out. And if you go over to perspective view, you can check it out in shaded. And this is, because it's an integrated plate, this is actually looking at the bottom of the keyboard. But yeah, I mean, it's like a tray, which holds the PCB. So for most designs, you'll understand what this part is for. Okay. All right, next step. So, what is the next step? I can cut the plate now. Sure, yeah, I'll do that. So I'm gonna hide this guy. I'm gonna grab the plate file and I'm gonna extrude it. And they're already capped objects, but if they weren't capped, then you just give them the cap command. All right, now we're gonna boolean this guy. Ooh, actually. We're gonna have to move these down slightly. Okay, so let's boolean with this guy. Oh wait, no, it's canceled. All right, boolean. I gotta highlight all of those for the boolean, except not that guy. This guy's not needed. And once this is done, we should have ourselves a case, the big reveal. Okay. So, actually that absolutely is not going to be needed again. So now we have something resembling a keyboard. I did want to do something interesting with the sides here, but I don't actually know what it's going to look like. But I guess we can just see. So I'm gonna try a tool here called contour, and yeah, 4 millimeters. No, 40 millimeters. 4.4 centimeters. There we go. So what I just created there was like little cuts in little lines in the keyboard that I can use every 4.4 centimeters. Okay. Now I'm going to offset this guy, this top one. Actually, I could just retrace this, but I guess I'll just grab this. Offset it the same distance. It doesn't really look that much. I'm gonna do it again. Alright, sure, that looks great. now I'm gonna yeah, that looks cool. Okay. Where is the center? There it is. What is the difference between that intersection? Oh, that's the wrong one. Okay, I'm gonna grab the center point of this line, and then I'm gonna grab the center point of this line. Are those different? Intersection, midpoint. I want the midpoint. Okay. So I don't really need these, and these are pretty distracting. Wait, come back. There, I want that one. Okay. Just for measurements, I'm going to create a little square here. I'm sure that looks like a great distance. Boom, 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 boom. Alright. Now I'm going to extrude both directions, and I'm going to mirror this guy onto both sides. Okay, and then I'm going to hide all this. Those little lines are still there. I don't think I'm going to need those. I think I'll just rebuild them. Alright, show. So now you got a case, and I'm going to be adding in some angles. Wait a second. I want this guy. Rotate. They're really distracting. Okay. And I want the center. Now I'm going to extrude that guy too, and mirror him again, so that all the same sides have the same little angle design going on. Now I'm going to show that, and now I'm going to take the base case, and I'm going to boolean these four shapes. Okay, so now you got a little angle here. That's cool. I'm gonna keep this for later because I don't remember if I'm gonna need it or not. I don't know. Okay, cool. So now what are the next few steps? Let's see. I wanted to add the underside. Okay, cool. So now I got that. Ooh, yeah, that's what I needed. Okay, well, I think I can reuse that. Yeah, so it's good that I saved that piece because I'm actually going to reuse it again. So now I'm going to extrude this 3 millimeters. 3 millimeters. That seems like a lot. Oh, I think it did both directions 3 millimeters. worked about twice as much as it should have. Okay, and now I'm going to, so you see, so I'm going to boolean it here, but I don't want to delete object. All right, I'm going to boolean it, don't delete input. So now I got this guy, which is the bottom of the case. And now I'm going to take this, rotate this again. Now throw this there. Yeah, I can keep that there. Now I'm going to extrude this. Just extra's fine. And now I'm going to mirror this across, so it's on both sides. And now I'm going to select this bottom piece. I'm going to do Boolean difference. So the way that I envision this design is as an aluminum case or steel case with a brass bottom. So so this bottom piece here, it's at an angle, because I would assume I would be milling the aluminum. Doing this angle wouldn't, the brass doing this angle wouldn't be so painful. But if I was doing this with acrylic, having that angle to the acrylic makes the process a lot more complex. So unless the bottom piece is metal, you should probably try to make the bottom piece have like squared edges. And so a way you could do that, if you wanted to take this design, is you could square off the bottom of this design, like, and then you could, for example, you could Boolean this, and like just run that line all across, straight down the side, and cut off, and then your edges will be flat, so they'll be flush with the they'll be flush with the sides of the acrylic too. But I'm not going to do that for this one because I don't want to. I think I want to have it as an angle like that. So the next changes I'm going to be making is I'm going to be adding some fillets in. I want to fillet this top surface. I want it to be bigger though. So 0.5. I kind of want it bigger. 0.75. Yeah, I like that. Okay, yeah, cool. And now I'm going to fillet edge on the bottom as well. 0.0625. This is just, I've never actually had to do this, but this is like if you were doing it by hand. This like radius is the amount you would use like a belt sander on steel or aluminum just to like round off sharp edges. Okay, the geometry got messed up there. What? Oh, it should be 0.0625. There we go. So now you want to select all those bottom edges. Cool. I hope that's not too sharp. But let's just say it's not for the sake of this. And now if we go to the render design, those extra lines there are just left over. I can actually remove those. Yeah. I'll move them to the side. Oh, there's another one. Okay. And so the bottom's all flush, and then there's this extra piece here, which is the whatever insert you decide. Say brass insert. And most of the time I do the cutouts like the front and back, but for this one I wanted to do it on the side for just to be different. Alright, so next I'm going to need to add in a location for the USB cutout. So on the designs I've used, the USB cutout is always between two keys, like precisely. So the way I handle that is I basically just void out a lot of space where the USB is. A lot of people will do like precise USB placement. I'm kind of like lazy with my USB port designs. I don't really like the metal touching the USB ports, and I'd rather give it more space than less space and not have like the PCB USB getting bumped around at all, especially when you're placing it in and like putting the PCB in. Yeah, that's just personal preference, I think, probably. So I'm gonna make this guy a little smaller. And I'm going to, so that looks about, that's not the right, that looks about good to me. So now I'm going to fillet these edges. That should be more than that. Is that good? Yeah, I could reduce this dimension a little bit. The USB, if I had a PCB that I was planning this for, I obviously could measure it, but this is all hypothetical. So I'm going to just do my best guess to see. I'm going to drop this down. Cool. That looks about good for a USB to me. And I'm going to fillet that. No, fillet edge. And I'm going to boolean this guy. I should have changed it back to delete input. But so now you got your little USB port there. I'm going to fillet the edges on that. I'm probably going to change that back to 0.125. Let's see what it looks like. Why is that? Fillet edge 0.25. Okay, for some reason it issues. I'm not sure what's causing them. There it is. Okay, well, I was able to do it with all of them. Also, another thing that I realized through my years of experience is sometimes USB plugs have different sizes, diameters, or like fitment problems, and I've had that on a few keyboards. So I kind of just wanted to like bypass that with my own keyboard. So for my keyboard design, my first one, which I had made called the Level, I actually just slice through. Actually, it's on the top. I slice through the top. But then on my V2 design, which is still in development, I like just slice straight through the bottom, and it also makes machining easier too. I'm sure it saves the CNC machine some time. Cool. So now we have this, and okay. So now you got more progress. Another part which you're gonna have to think about if you're designing a case is like the screws. So I usually, the way that you usually have an idea of what size screw you're tapping. So I always use M3 because I just like it. So you need to call out basically like the location of where the screws are being tapped. There it is. But you don't actually need to put the screw designs in the model. I've never had to do that. There's tools for it. I've never actually even used them. That's even too big. And you can also do countersinking on your bottom piece if it is being milled. So let me just mirror these to the other side really quick. Let's check them just so they landed correctly. It looks good to me. So now we got our, I hope I'm not giving you guys vertigo. So now we got our screw holes there. And now you got this bottom piece. What you can do is you can add the countersinking on that piece if you want. You should probably have the screw dimensions. You can find screw files when you're buying screws for like you can actually get like the STL files for them, and you can just make sure you're getting the dimensions correctly. But I'll do a rudimentary approach to that here. So what I did is I just copied those circles from one side here, and then one set of them I extruded them, and then I'm just going to create a little countersinking. How should I do this? These are tiny. Okay. Okay, is that touching? Yeah, cool. So, I'm gonna reduce this height. And then I'm going to get the center of that, get another line there just to measure the center easier. And then I'm gonna guess what the bottom of the screw is. So I'll say it's 2 millimeters. And then I'm going to create a little line here to there. And then I'm going to revolve. And you want to grab the center of that. Oh man, it's going the wrong way. It could probably be bigger than that. I'm gonna do 3 millimeters. I think that I need to have another line here. Where did that guy connect to? Scale him back down. This tool always confuses me because you have to use like a different view for it. See, now it's revolving the other way. Oh yeah, you need to select vertically. Okay, yeah, you need to select the part of the circle that's revolving. Okay, I think I got it. Alright, hold up. Okay. There it is. There we go. Alright, now I can cap that guy. And now let's show. Alright. We did it. I guess I can hide that again. So now I'm gonna need to throw this guy. Hopefully I kept those lines there. Those measurement lines. And we can move him to the bottom of that circle. Those should be the same. Now let's get one more. And move him to the same location. I like having extra lines for measurement. That's just what I like to do. I don't really like messing with my snaps either. Okay, cool. And alright, now what you need to do is select all 3 of these, and you gotta throw them on the other side too. Okay, so now you got those. Now you're gonna take this guy and you're gonna boolean the screw countersinks out. Oh, I still don't have the delete input on. Okay. And now I'm going to select this, and you want to put these curves, group them with the same object so that they're on the object, so that when you send the file, you know they're there for sure. Yep, so you want one of all those curves. Now you're going to group them together. Ugh. Alright. I kept hitting join. Alright, now you're going to group them. Now you're going to take this guy and you're going to group those. Now you're going to hide that. Now you're going to delete everything. Everything. And now you should have those countersinks there nicely. And yeah, so now that bottom piece is there, the USB cutouts there, and the rest of the keyboard's there. So that's just this should be good to go. So this is my keyboard with no name. You can see the two pieces there. Let me see if I can change the viewport, view, whatever perspective. Yeah. So this is something. This is like the basics of how I make a keyboard and how I mess around with different aesthetics and looks. Yeah. Yeah. So hopefully this all recorded correctly and such, but yeah, I mean that should wrap it up for this first video. Thank you everybody for watching. If you like it or you want to see me try to create other stuff, always let me know, and definitely check out our podcast at theboardpodcast.com. We do it every week and it's fun, so you should join in the shenanigans. We also have a lot of giveaways. Like every week we got giveaways. Okay, cool. All right, thank you everybody, and have a good rest of your